Hi everyone. So I'm going to do a little video tutorial. This will be your first one, so hopefully you get some benefit out of it. I'm going to try to do a lot of these, so if it doesn't really work out for you, just come and see me and I'll be happy to explain things to you one-on-one. But I'm doing this as a kind of initiative so that you can kind of help yourself work through a problem at home when maybe I'm not there, or if you don't have a tutor, or if you're really confused. So the first thing that we're going to be doing is breaking down vectors into components. And if you remember from the triangle review, the first part of of our course, we learned about the hypotenuse and how they could be broken down into an opposite and an adjacent. And this is exactly what we're going to be doing here. So it's not very different from what you've already done. So I have some examples here. I uploaded the empty ones here, and I'll also upload the corrected ones later so that you can have a chance to try it out on your own and then check your answers to see if they're right. But basically what I want you to do is I've given you these vectors, right? So this is a vector that's 13 newtons in this direction, and I want you to break it down into its x component, so there's my x-axis, and its y component, all right? So what we can do first is just, if it makes it any easier for you, is make a triangle. Right? That's how it looks like, and here we have a 30-degree angle, and this length is 13 newtons, right? So what we need to do is find the opposite, and what we need to do is find the adjacent to this angle, right? And that'll give us the x and y components. So this here, this bottom part, would be the x component, right? Because it's going along this axis. So for the x component, I'm just going to separate them out. We know that because of SOHCAHTOA, and I'll write that down here, SOHCAHTOA. We know because of SOHCAHTOA that if we want to find the adjacent, we have to use cosine. So the cosine of 30 degrees is equal to the adjacent over the hypotenuse, which in this case is 13 newtons. Alright, so if we do some algebra, we can just do this here. 13 newtons times cosine 30 degrees is equal to our adjacent. And that's our x vector. So let's do that on the calculator. So 13 cosine 30 is equal to 11.26. So the adjacent is equal to 11.26, and our units here are newtons. So we're going to leave that in newtons, and that's because it's a vector, it's in the x direction, Alright, let's do the same thing with the y here. So we know from here, if we want to find the opposite, we got to use sine. So it's sine 30 is equal to opposite over hypotenuse, which is 13 newtons, right? And if we do the algebra, it's 13 newtons sine 30 is equal to 6.5 newtons. So the opposite is equal to 6.5 newtons in the y direction. Alright, so here we broke it down into an x component and a y component. And if you're really unsure about your answer, what you can do is use Pythagoras, right? Because you have this length here, which is 11.26, and you have this length, which is 6.5, and if you use a squared plus b squared is equal to c squared, we can figure out if c of this length is equal to our original 13 newtons. That's just to double check your work. You really don't need to do this all the time. Oops. So if I did it right, my C is equal to roughly 13.00, and that's exactly what I started off with, and that's so I know I did my work correctly. Alright? Just going to leave that up for a couple seconds. I won't do B, because I want you to try that on your own, but I will do D for you. Alright? And then B and C, I'll write out the problems and I'll just scan them and upload them. I won't put them in this video. So for D, it's a little bit different because the angle is all the way down here, right? But if you remember in math, when we started doing Cartesian planes, right, we had, this was the plus quadrant. This was the the minus plus quadrant. The minus plus quadrant. This is the minus quadrant, and this is the plus minus quadrant. And what that means is, if you're in this box here, you're in the plus x direction and in the plus y direction. Here you're in the minus x direction because it's on the other side of this y-axis, and you're in the plus y direction because you're above the 0 here, right? Same thing here, minus direction, and here plus minus direction, so plus x minus y direction. All right, but we won't even take that into consideration until we write down our answers, because up until then we have a right angle triangle again, so we can draw it out for ourselves like that. You see that right angle triangle? Not too tough, right? All right, so we need to break it down into the y and into the x. So let's do it. So x is equal to, let me write down my SOHCAHTOA, because even I still rely on that trick. So if I want to find the x, which is here, it's opposite, so I have to use sine. So sine 30 is equal to opposite over hypotenuse, which is 75 newtons. All right, and therefore my opposite is equal to 75 newtons times sine 30, and therefore opposite is equal to 37.5 newtons. Okay, and on the y direction, it's cos is for adjacent over hypotenuse, so cos 30 is equal to adjacent over hypotenuse, which is 75 newtons. All right, and if we do the algebra, it becomes roughly 64.95. All right, so now we have to give our final answer and which directions we're going. So the x is going this way, so that's in the negative x direction. So the answer would be 37.5 newtons in the negative x direction, and 64.95 newtons in the negative y direction. Is that simple enough? Would it make things a lot more complicated for you if I changed the x and y into east, north, west, south? Not really, right? Because instead of saying in the negative x direction, you would say 37.5 newtons west direction and 64.95 newtons in the south direction. All right, so your resulting vector is somewhere between the 75 and the south. Sorry, it's between west and south at a 30-degree angle. Okay? Thank you.